So you want to learn how to make the first commercially successful video game, Pong. But the original Pong game is just black and white, which I think it's really lame. Instead, you will be learning how to make a glowing Pong. In this video, I will be guiding you through the entire game creation process, so if you are just a beginner and you want to make your first game using Unity Game Engine, this is the tutorial for you. You will be learning how to make a simple racket controller, making the ball move and bounce, adding a scoring system, and lastly, we will bring this game to another level by adding music, sound effects, and use post-processing to add the glowing effect. Grab a cup of water and sit up straight because we are about to make a glowing Pong together. Let's begin. Firstly, we will need to create a new game project. Make sure you select the 2D template as we are making a 2D game, and we will name our project Glowing Pong. Alright, let's create our game project. Once it finishes loading, we will need to configure our game project. Click on the File tab at the top of Unity and then Build Settings. In the Build Settings window, we want to make sure the platform is set to PC and Mac as this game will be played on the computer. Close the Build Settings window and take a look at your game panel. Make sure the game resolution is set to 16 by 9 and your game should be in landscape mode. Next, we are going to import the game assets. I've created these assets myself and I will leave a link in the description below for you to download it. Once you have imported the game assets, it's a good habit to create a few folders to keep your game project neat and organized. So let's create a new folder called Sprites and a folder called Scripts. Lastly, we want to drag all our sprites into the Sprites folder. We will first set up our main menu scene. So firstly, we want to rename the scene to Main Menu. Next, we want to change the color of the background, so let's click on the main camera object and change the background to a black color. Next, let's head over to our Sprites folder and we want to add the glowing Pong text sprite into our game. So simply drag it into the hierarchy. Now if you take a look at the Inspector tab, you can see that our glowing Pong text object has a sprite renderer component. The sprite renderer component allows us to render our sprites and control how it visually appears in a scene. Now we want to change the color of our sprite. So click on the color option and change it to whatever color you want. I'm going to give it a purple color. Now we want to move the sprite up a little. So under the transform component, we will give the position Y a value of 2.8. Next, we need to create a button that will bring us over to the game scene. So let's right click on the hierarchy tab, head over to UI, and create a new button. Let's rename it to Play Button. You can see that the button we created is a child of the canvas object. Now let's select the canvas object, and under the canvas scaler component, we want to change the UI scale mode option to Scale with Screen Size. Since our game resolution is set to 16 by 9, we want to change the X value to 1600 and Y value to 900. Next, let's select our Play Button object and we want to assign the Play Button sprite into the image component. So simply drag it and drop it in the source image option. I'm going to give it a green color. Now we want to move the button to the center of the scene, so under the Rect Transform component, we want to change the position X and position Y value to 0. Next, we are going to resize the width to 370 and height to 150. Lastly, expand the Play Button object and you can see a child object under it called Text. Go ahead and delete it as we won't be using it. Alright, we are done with the Play Button. And now, we need another button for us to quit the game. So let's duplicate the Play Button object. With the Play Button object selected, simply press Ctrl plus C on your keyboard and then Ctrl plus V. You should see another Play Button object being created. Now we are going to rename it to Quit Button. Next, we are going to assign the Quit Button sprite to the source image. I'm going to give it a red color. And lastly, we want to move the button down a little, so let's give the position Y a value of -200. Alright, we are done setting up the UI for our main menu scene. Now we need to do some coding for us to move to another scene when we click on the button. So let's head over to our scripts folder and we want to create a new C# script called change scene. Let's open up the change scene script. We can go ahead and delete the start and update function as we won't be using it. And at the top, we want to add the Unity Engine.Scene Management namespace. The reason why we need the scene management namespace is because we will be using a function called loadScene from the Scene Manager class. And to access the Scene Manager class, we need to add the Unity Engine.Scene Management namespace. Next, we want to create a function called moveToScene with an integer parameter called SceneID. In the function, we will simply call the loadScene function from the Scene Manager class. So every scene that we create will have an unique ID assigned to them. I will explain more later back in Unity. But for now, you just need to understand that what we are doing here is simply loading the scene ID of the scene which we want to move to. Next, we want to create another public function called quit. This function will be called whenever the player press on the quit button. So to quit the game, we will just need to do an application.quit. Alright, we are done with our change scene script. So let's save the script and head back to Unity. Now let's attach the change scene script to the glowing Pong text object. So simply select the glowing Pong text object, drag the change scene script, and drop it in the inspector tab. Now let's select our play button object and we want to call the moveToScene function whenever a player clicks on the button. Since our change scene script is attached to the glowing Pong text object, we first need to assign the object and then call the moveToScene function. Now nothing is going to happen right now if we were to click on the play button. Reason being, we currently only have one scene. So let's head over to our scenes folder and we want to create another scene which we will name it Pong Game. So when we click on the play button, we want to move over to the Pong Game scene. Now let's head over to the File tab at the top left of Unity and we want to open up Build Settings. In the Build Settings window, you can see that our main menu scene has been assigned an ID of number 0. Now the scene with the ID of number 0 will be the scene we start off with, which means whenever we start the game, we will start off with the main menu scene. Now let's add our Pong Game scene into the Build Settings as well. So we just need to simply drag and drop it in. Now you can see that our Pong Game scene is assigned to an ID of number 1. Which means if we want to move over to the Pong Game scene, we just simply need to change this value over here to 1. We are done with the play button, so let's head over to the quit button object. And we want to call the quit function whenever we click on the quit button. Alright, let's enter play mode to try it out. Firstly, let's try out the quit button. You will notice that nothing is happening. And the reason is because we are currently testing it in the editor. So nothing will happen over here. But once we build our game, you will see that pressing on this quit button will close the entire game. Now let's try the play button. Alright, you can see that we move over to the Pong Game scene. Perfect, we are done setting up our main menu. So next up, we will be building the actual game itself. Now let's head over to our Pong Game scene. Firstly, we want to change the color of the background, so let's click on the main camera object and change the background to a black color. Next, we want to create an empty game object and rename it to Borders. Click on the Borders object. We want to head over to the Inspector tab and take a look at the transform component. We want to make sure the values of position and rotation are all at 0 and scale values are at 1. If your transform component has a different value, simply click on the 3 dots icon on the right and click on Reset. Next, we want to right-click on the Borders object and create another empty game object. We will rename it to Right Border. So right now, the Borders game object is the parent of the Right Border object. With the Right Border object selected, we want to click on the Add Component button and we want to add a Sprite Renderer component. Now let's select the Sprites folder and let's drag the vertical border sprite into the Sprite Renderer component. Once you are done, you should see a white vertical border appearing in your scene. Now we want to head down a little, and under the additional settings option, you should see an order in layer field with a value of 0. Now we want to change the value to -100. The order in layer field allows us to decide which sprite we want to give priority to. So basically, the lower the value, the further back the game object appears. The higher the value, the closer the game object appears. That is why we are giving our border a -100 value, because we do not want it to appear in front of any other objects. Since this is our right border, we want it to be on the right side of the scene. So under the transform component, we want to change the X position to a value of 8.7. Your border should now be on the right side of the scene. Lastly, I'm going to change the border to a purple color. You don't have to follow me exactly, you can choose any other color you want. Now we want a border on the left side of the scene as well, so let's select the right border object and we want to duplicate it. You should see another right border object appearing. Let's rename it to left border, and we want to change the value of X position to -8.7. Now that we have our borders on the left and right side of the scene, we need one for the top and bottom of the scene as well. So let's duplicate the left border object and we want to rename it to bottom border. Let's drag the horizontal border sprite into the sprite renderer, and we want to give the X position a value of 0 and Y position a value of -4.8. Now we need a border at the top as well, so let's duplicate the bottom border. Rename it to top border and change the Y position value to 4.8. Alright, we now have borders around the scene, but we need a line in the middle to indicate the halfway point. So I'm going to duplicate the left border object. Let's rename it to middle line. Drag the middle line sprite into the sprite renderer and change the value of X position to 0. Now that we are done setting up the borders, we need to set up the ball and player racket. So let's create an empty game object called ball, and we want to add a sprite renderer component. Next, let's drag the ball sprite into the sprite renderer. You should now see a white ball in your scene. You can change the color of the ball if you want to, but I'm going to just leave it as white color. Alright, now let's set up our player racket. Create another empty game object and we will name it player1. Let's add a sprite renderer component as well, and we will drag the racket sprite into the sprite renderer. So we want player1 to be on the left side of the field, so let's change the X position to -7.5. And I will give player1 a green color. Alright, let's set up one more racket for player2. So let's duplicate player1 object and we will rename it to player2. We want to change the X position value to 7.5, and I'm going to give player2 a red color. Perfect, we are done setting up our game scene. But before we move on to the next chapter, I want you guys to take a look at your hierarchy and make sure you have these game objects in your game scene. Alright, now it's time to make our ball move and bounce. If we were to enter play mode right now, you can see that the ball isn't moving. Well, that is because in order for our ball to move, we will need a rigid body 2D component. So let's select our ball object, click on the add component button and search for rigid body 2D. Adding a rigid body 2D puts this game object under the control of the physics engine. This way, we will be able to control the ball from scripts. Next, we want to change the mass to 0.0001, which is the lowest possible value, and the collision detection option to continuous. This is to ensure that our ball object will always collide with the borders. Now if we head down a little, you can see an option called constraints, and we want to expand it. Now what we want to do next is to freeze the Z rotation. The reason why we want to check this option is because we are making a 2D game. And since it's 2D, we will only be using the X and Y axis. We do not want our ball object to rotate along the Z axis. Now if we were to enter play mode, you can see that the ball is able to move, but it falls out of the screen. Now you might be wondering, why is our ball falling out of the screen when we have our borders in place? And the reason is because there are no colliders on the ball and borders to detect collision. So what we want to do now is to add a 2D collider to our ball and borders. So let's exit Play Mode, and with the ball object selected, we want to click on the Add Component button. Now let's search for Circle Collider 2D. If we were to zoom in to our ball object, you should be able to see a green circular outline around our ball. So this is the collider for our ball object. Alright, let's zoom back out, and we want to add a collider for our borders as well. With the right border object selected, we want to click on the Add Component button and search for Box Collider 2D. Now we want to do the same step for the left, bottom, and top border. Let's enter Play Mode, and you can see that our ball object no longer falls out of the screen. Exit Play Mode, and what we want to do now is to make our ball bounce. I told you earlier that we need a rigid body 2D to make the ball move. So to make the ball bounce, we need a physics material. So we want to select the Assets folder, right click, hit over to Create, 2D, and click on Physics Material 2D. We will name it Ball Material. If we were to click on our ball material, you can see a friction and bounciness value. Friction is how much the speed rests off when it's moving along a collider. But in this Pong game, we don't need any friction on the ball, so let's change the value to 0. Now the bounciness value determines how strong the bounce will be when it touches a collider. So the higher the value, the stronger the bounce. So we are going to give a value of 1 for the bounciness. Reason being, we want the ball to bounce back at the same speed. If we were to use a value larger than 1, the ball will be bouncing back at a faster speed, and that's not what we want. Let's select our ball object, and we want to drag the ball material into the Circle Collider 2D component. Alright, let's enter Play Mode to try it out. Alright, as you can see, our ball bounces back when it collides with the border. Alright, now we want to make our ball move left and right instead of just dropping down when the game starts. So firstly, we want to select our ball object and take a look at the rigid body 2D component. We want to change the gravity scale to 0 so that there isn't any gravity pulling the ball down. Now we need to do some coding to make the ball move. Let's head over to our scripts folder, and we want to create a new C# script called Ball Movement. Alright, let's open up the ball movement script. We do not need the update function, so let's go ahead and delete it. And above the start function, we want to create a public float variable called start speed. So this variable will determine the starting speed for our ball. Next, we want to create another public float called extra speed. This will determine how much speed the ball is going to increase every time it bounces off the racket. If the speed of the ball is always the same, it's going to be a really boring game. Therefore, to make it more challenging, we want to slightly increase the speed of the ball whenever it bounces off a racket. Next, we want to create another public float variable called max extra speed. This variable will determine the maximum extra speed for our ball. The reason why we need to set a maximum speed is because we do not want the speed to keep increasing until it's totally impossible to catch. So once the speed of the ball reaches the maximum, we do not want to increase the speed anymore. Next, we want to create a private integer called hit counter. This is for us to keep track on how many times the ball has been hit by the racket. We will just set it to 0 by default. And lastly, a private rigid body 2D variable called RB. We need this variable because we will be using very simple physics to move our ball. In the start function, we want to fetch the rigid body 2D from our ball game object. So RB equals to getComponent rigid body 2D. Now below the start function, we want to create a new public function called moveBall with a vector2 parameter called direction. Next, we want to normalize the direction variable, so direction equals to direction.normalize. Now we want to create a float type variable called ball speed. This ball speed variable will determine the current speed for our ball. So it will be equals to the start speed plus hit counter times extra speed. This is so that we are able to increase the speed of the ball continuously. Let me give you an example. Let's say we give our start speed variable a value of 100 an extra speed variable a value of 10. So the value of our ball speed variable will be 100 plus 0 times 10. The reason why our hit counter is 0 is because the ball hasn't been hit by the racket yet. So in this case, 0 times 10 is 0 and 100 plus 0 is still 100, which means the ball speed variable have a value of 100. So now, let's say the ball is moving and it gets hit by the racket once. So now the hit counter variable have a value of 1, so 1 times 10 is 10, and 100 plus 10 is 110, which means the ball speed variable now have a value of 110. So this is how we increase the speed of the ball continuously during the game. So right now, we want to apply this ball speed variable to the physics aspect of our ball, which is the rigid body 2D. So RB.velocity equals to direction times ball speed. In order for our ball to move, we need to call this moveBall function. So how do we do it? We do it by calling this moveBall function within a coroutine. So to do that, we create a public IE numerator called launch below our start function. So within the launch coroutine, we need to first set the hit counter to 0, and then we want to make the game wait for 1 second before the ball starts moving. This is so that the players can get ready. So to do that, we do a uit return new, wait for seconds with a value of 1. So that means we are making our game wait for 1 second before we launch our ball. Next, we need to call the moveBall function. And since our moveBall function has a vector2 parameter, we need to do a new vector2 and pass a value. So we will give the x coordinate a value of -1 and y coordinate a value of 0. Basically, this line of code will result in the ball moving to the left because we gave the x coordinate a value of -1. Now let's head over to the start function and we want to call our launch coroutine. So to do that, we do a start coroutine launch. Alright, save the script and head back to Unity. Let's select the ball object and we want to attach the ball movement script to the ball. Once you have attached the script, you should see the start speed, extra speed, and max extra speed variable. So let's give our start speed a value of 5, extra speed a value of 1, and max extra speed a value of 5 as well. Alright, let's enter play mode to try it out. Alright, you can see that the ball waits for 1 second before moving to the left. The reason why it passes through the racket is because we have yet to set up the colliders for our rackets. So let's exit play mode and add the collider. Select the player 1 game object and we want to add a box collider 2D. We want to do the same for player 2 game object as well. So let's select it and add a box collider 2D. Alright, let's enter play mode to try it out again. Perfect, the ball now bounces off the racket. Now if you take a look at the speed of the ball, you will notice that it's constantly the same and the speed of the ball doesn't increase when it's bouncing off the rackets. So let's exit play mode and head back to our ball movement script. Below our moveBall function, we want to create another public function called increase hit counter. So firstly, we need to do an if statement to check if our hit counter times extra speed is less than our max extra speed. So if the condition is met, we will increase the hit counter by 1. So hit counter plus. Alright, we are done with our ball movement script. This increase hit counter function hasn't been called yet, and we won't be calling it in this script. So let's save this script and head back to Unity. Alright, now we want to make our player 1 and player 2 racket move up and down. So to do that, we need to add a rigid body 2D component. If you remember earlier, when we want to make our ball move, we added a rigid body 2D to our ball as well. So let's select our player 1 object and add a rigid body 2D component. We want to change the gravity scale to 0, freeze the Z rotation and X position as well. The reason why we need to freeze the X position is because our racket won't be moving left and right. Instead, it will just be moving up and down. Let's do the same step for player 2 object. Select player 2 object, add a rigid body 2D component, change the gravity scale to 0, freeze the Z rotation and X position. Now we will need to create two scripts for both our players. We want to create a new C# script called player1 and create another C# script called player2. Let's open up the player1 script first. Firstly, we want to create a public float variable called racket speed. This will determine the movement speed for player1's racket. Next, let's create a private rigid body 2D variable called RB and a vector2 variable called racket direction. Now in the start function, we want to fetch the rigid body 2D from our player1 object. So RB equals to getComponent rigid body 2D. Next, we want to create a fixed update function below our update function. The difference between update and fixed update is that the update function is called once per frame. So almost anything that needs to be adjusted regularly happens here. Example like timers and detection of inputs are usually done in the update function. On the other hand, fixed update is used for being in step with the physics engine. So anything that needs to be applied to the rigid body should happen in fixed update. Now in the update function, we need to first check if player1 pressed a button and save that within a float. So we are going to name our float direction Y, and it will be equals to input.getAxisRaw vertical. This line of code means that we are getting the input from player1, and the input I want to have is getAxisRaw, which means it doesn't matter how hard or soft player1 press on the button, it will simply take the raw value. And then we have the axis name, which is vertical. So how did we get this axis name vertical? Let's pause our coding for a moment and head back to Unity. Now let's click on the edit button on the top left corner, click on the project settings, and then select input manager. Now if you expand axis, you can see the various axis name created, and one of them is called vertical. And if you expand the vertical option, you can see the name is set as vertical, and if you remember back in our player1 script, we actually used this axis name. Now if we go down a little, you can see that the negative button is set as down, and the positive button is set as up, which means if player1 press on the down arrow key, the racket will be moving downwards, and if player1 press on the up arrow key, the racket will be moving upwards. And right below it, we have the alternative button for both positive and negative, which means if player1 press on the S and W key, the racket will be moving up and down as well. Since this Pong game is a local multiplayer game, we want both player1 and player2 to be playing on the same keyboard, which means we will need another vertical axis for player2. So to add another axis, simply just increase the size value by 1. In my case, I currently have 18 axes, so I'm going to increase it to 19. Once you have increased the value by 1, you will see a duplicate of the last axis. So let's expand it, and we want to rename this axis to vertical 2. Since player 2 will be on the right side of the scene, we want player 2 up and down control to be the up and down arrow key. So let's set the negative button to down and positive button to up. Let's head back to our vertical axis. Firstly, we want to remove both alternative buttons, and since player 1 will be on the left side of the scene, we want to set the negative button to S and positive button to W. Lastly, we want to make sure the other values of vertical 2 axis are the same as vertical axis. So let's remove the Alt positive button, change the gravity value to 3, change the sensitivity value to 3, and lastly, check the snap option. I want you guys to check both your vertical and vertical 2 axis, and it should have these values. So we have player 1 using the vertical axis, and we'll be using the W and S key to move the racket. Player 2 on the other hand will be using the vertical 2 axis, and will be using the up and down arrow key to move the racket. This way, we can have both player 1 and player 2 playing on the same keyboard. Alright, once you are done, let's head back to the player 1 script. Now back in the update function, we want to set the racket direction variable to be equals to new vector2. We will give a value of 0 for the x coordinate and use the direction y variable for the y coordinate. And we will add .normalize at the end to ensure our racket's movement being consistent. Like I said earlier, we are doing all this in the update function because detection of inputs are usually done in the update function. Now in the fixed update function, we want to apply the racket speed variable to the physics aspect of our racket, which is the rigid body 2D. So rb.velocity equals to racket direction times racket speed. And like what I've said earlier, anything that needs to be applied to the rigid body should happen in fixed update. And that is why we are doing this in the fixed update function. Alright, save the script and head back to Unity. Let's attach the player1 script to our player1 object. And we want to give our racket speed a value of 15. Alright, let's enter play mode to try it out. Perfect. When we press on the W and S key, the player1 racket will be moving up and down. Let's exit play mode, and right now we want to open up our player2 script. Alright, let's head back to our player1 script, and we want to copy the codes from the racket speed variable all the way to the fixed update function. Let's head back to our player2 script, and we want to paste it over the start and update function. All we have got to do now is to simply change the axis name to vertical2. Let's save the script and head back to Unity. Attach the player2 script to our player2 object, and we want to give the racket speed a value of 15 as well. Make sure the racket speed values are the same for both players. Alright, let's enter play mode to try it out. Let's test player2 racket with the up and down arrow key. Alright, it's working perfectly. Let's exit play mode. And right now, we want to make our ball bounce off correctly. So when the ball bounces off the top half of the racket, we want the ball to bounce upwards. On the other hand, when the ball bounces off the bottom half of the racket, we want the ball to bounce downwards. So to achieve that, we want to create a new C# script called ball bounce. Alright, let's open up the ball bounce script. Go ahead and delete the start and update function as we won't be using it. Firstly, we need to reference our ball movement script. So let's create a public ball movement, and we will name it ball movement with a small letter B. The reason why we need a reference to our ball movement script is because we have a function called increase hit counter which we want to use over here. Now let's create a private function called bounce. And we need the collision 2D parameter, which we will name it collision. Now in order for us to know whether the ball should bounce upwards or downwards, we need to know the ball position, the racket position, and the racket height. So let's create a new vector tree which we will call ball position. And it will be equals to transform.position, which means we are getting the position of our ball. Next, we need to create another vector tree called racket position, and it will be equals to collision.transform.position, which means we are getting the position of the object our ball had collision with. Next, let's create a float called racket height, and it will be equals to collision.collider.bounce.size.y. This is for us to know which part of the racket did the ball hit. Next, we need to know if the ball bounces off player 1 or player 2's racket. So let's create a new float called position x. And we need to do an if statement to check if the collision is player 1's racket. So if collision.gameObject.name equals to player 1, we want to set position x to 1. Else, we want to set position x to -1. Now that we have our position x, we now need to calculate our position y. So let's create a new float called position y, and it will be equals to ball position.y minus racket position.y divided by racket height. Next, we want to call the increase hit counter function from our ball movement script. So ball movement.increase hit counter. Lastly, we want to call the move ball function from our ball movement script, which needs a new vector too, and we will put the position x variable for the x coordinate and position y variable for the y coordinate. Alright, we are done with our bounce function. and we want to call this bounce function whenever we have a collision. So to detect collision, we need to create a private void on collision enter 2D with a collision 2D parameter called collision. Now we need to check if the ball had collision with player 1 and player 2 object. So if collision.gameObject.name equals to player 1 or collision.gameObject.name equals to player 2, we want to call the bounce function. Alright, save the script and head back to Unity. Let's attach the ball bounce script to our ball object, and we want to reference our ball movement script. Alright, let's enter play mode to try it out. Perfect, the speed of the ball increases as it bounces off the racket, and the ball is bouncing correctly. Let's exit play mode and we want to set up our scoring system. Firstly, we want to set up the UI for our scoring system. So let's right click on the hierarchy, head over to UI, and we want to create a new text. Let's rename it to player 1 score. You can see that our player 1 score object is a child of the canvas. Let's select our canvas object, and under the canvas component, we want to change the render mode to screen space - camera. Next, we want to attach our main camera object to the render camera field. The reason why we are doing this is because we do not want our text to be in front of the ball object. Next, let's head down to the canvas scaler component, and we want to change the UI scale mode option to scale with screen size. Since our game resolution is set to 16:9, we want to change the X value to 1600 and Y value to 900. Alright, we are done setting up the canvas. Now let's select the player 1 score object. We want the text to appear on the left side of the screen, so let's change the value of position X to -360 and position Y value to 0. Next, we want to resize the width and height to 400. Let's head down to the text component. We want to change the text to 0, font size to 300. Lastly, change the font alignment to the middle. Alright, we are done setting up player 1 score. So now let's do player 2. Simply copy and paste player 1 score object, and we want to rename it to player 2 score. Lastly, we want to change the position X value to 360. Alright, we are done setting up the score UI. So right now, we need to create a new C# script called Score Manager, and let's open it up. Go ahead and delete the start and update function as we won't be using it. Next, we want to create two private integer called player 1 score and player 2 score, and we want to set both of these variables to a value of 0. These two variables are for us to keep track of the player score. Next, we want to create two public text type variables called player 1 score text and player 2 score text. These two variables are references for the player 1 score and player 2 score object back in Unity. Now since our text type variable is a UI element, we need to add the UnityEngine.UI namespace at the top to access the properties of UI elements. Next, we want to create a new public function called player1go. So this function will be called whenever player 1 scores a goal. So firstly, we want to increase the score, so player 1 score ++. Next, we need to update the score text, so player 1 score text.text equals to player 1 score.toString. The reason why we need to use the toString function is because our player 1 score variable is an integer. So we need to convert it to a string in order to pass it to our text type variable. Alright, we are done with this function. So let's create another public function for player 2 called player2go. This function will be called whenever player 2 scores a goal. So firstly, player 2 score ++ and then player 2 score text.text equals to player 2 score.toString. Alright, we are done with the score manager script. We will be calling the player 1 go and player 2 go function in the ball bounce script. So let's save the script and head back to Unity. Now let's open up our ball bounce script. So firstly, we need a reference to our score manager script, so public score manager, and we will just name it score manager with a small letter s. Let's head down to the onCollision enter 2D function, and over here, we will do an else if statement to check if the ball collided with the right border. So if the ball touches the right border, we will need to give player 1 a point. So we will simply just call the player 1 goal function from the score manager script. Next, we will need to do an else if statement to check if the ball collided with the left border. So if the ball touches the left border, we will need to give player 2 a point. So over here, we will call the player 2 goal function. One very important thing to take note, make sure your right and left border object back in Unity is named exactly the same as what you have typed here in the script. Alright, let's save the script and head back to Unity. We will attach the score manager script to the borders object, and we will need to assign the player 1 score and player 2 score object. Next, let's select our ball object, and we will need to assign the score manager script. Since our score manager script is attached to the borders object, we simply need to just drag the borders object and assign it to the ball bound script. Alright, now let's enter play mode to try it out. As you can see, whenever the ball touches the right border, player 1 score increases by 1, and when the ball touches the left border, player 2 score increases by 1. Our ball is constantly moving even after a player scores a point, and we do not want that. If any player scores a point, we want the ball to go back to the middle, and if it was player 1 that scores a point, we want the ball to start off by moving to the right so that player 2 can start. So let's exit play mode, and we want to head over to our ball movement script. Firstly, we want to create a new public boolean called player 1 start, and we will set it to true. So whenever player 1 start variable is true, we want player 1 to start off with the ball. And when this variable is set to false, we want player 2 to start instead. Next, below the start function, let's create a new private function called restart ball. This function will be called whenever a player scores a point. So firstly, we want to stop the ball from moving, so rb.velocity equals to new vector 2, and we will give a value of 0 for the x and y coordinate. Next, we want the ball to move back to the center, so transform.position equals to new vector 2, and we will give a value of 0 for the x and y coordinate as well. Next, let's head over to the launch function, and we want to call the restart ball function over here. Now let's head down a little, and we want to do an if statement to check if player 1 start equals to true. If it is, we will call the moveBall function with a value of -1 for the x coordinate. Else, we will call the moveBall function with a value of 1 for the x coordinate. Basically, this means that if player 1 start variable is true, which means player 1 is starting, the ball will move to the left. Else, player 1 start variable is false, which means player 2 is starting and the ball will move to the right. Alright, let's save the script and head back to Unity. Now let's open up our ball bound script. Let's head down to the onCollision enter 2D function. So if the ball collided with the right border, which means player 1 scored a goal, we want to set the player 1 start variable from the ball movement script to false. Next, we want to call the launch coroutine from the moveBall script as well. Let's head down a little. If the ball collided with the left border, we want to set player 1 start variable to true and call the launch coroutine as well. Alright, we are done with this script, so let's save it and head back to Unity. Alright, let's enter play mode to give it a try. If player 1 was to score a goal, you can see that the ball restarts in the center and player 2 will be starting off with the ball. Now if player 2 was to score a goal, the ball restarts in the center as well and player 1 will be starting off with the ball. Now we need to set up a game over scene once a player reaches a certain amount of points, else this game will keep going on forever. So let's head over to our scenes folder, and we want to create a new scene which we will name Game Over. Let's head over to the Game Over scene. Firstly, we want to select our main camera object and change the background to a black color. Next, we want to add the Game Over text sprite into our game. So let's head over to our sprites folder and simply click and drag it into the hierarchy. Next, we want to move it up a little, so let's change the Y position to 2.8. Head down to the sprite renderer component and I'm going to change it to a purple color. You can choose any colors you want. Next, we want to create a new button, so let's right click on the hierarchy tab, UI, and button. Let's name it Replay Button. Similar to what we did back in our main menu scene, select the canvas object, head over to the canvas scaler component, and we want to change the UI scale mode to scale with screen size. We will change the X value to 1600 and Y value to 900. Let's select the replay button object, and I'm going to assign the replay button sprite to the source image. Under the rect transform component, we want to change the position X and position Y value to 0, and resize the width to 370 and height to 150. I'm going to change the color to a green color. Lastly, we want to expand the replay button object and delete the text object under it. Alright, we are done with the replay button. Now we need one more button for the main menu. So let's duplicate the replay button object and rename it to main menu button. Next, we want to assign the main menu button sprite into the source image. And I'm going to change it to a red color. Lastly, we want to shift the button down, so under the rect transform component, we want to give position Y a value of -200. Since this scene is newly created, we need to open up our build settings window and add the Game Over scene into our build settings. So the Game Over scene has been assigned to a scene ID of number 2. Let's close the build settings window and we want to attach the change scene script to our Game Over text object. Let's select the replay button object and we want to call the move to scene function when we click on the replay button. And we want to move to the Pong game scene, which has a scene ID of 1. Now let's select the main menu button and we want to call the move to scene function as well, but this time round, we want to move over to the main menu scene which has a scene ID of 0. Alright, now we want to head back to our score manager script. Firstly, we want to create a public integer called score to reach. This variable will determine how much score the player must reach in order for the game to end. All the way at the bottom, we want to create a new private function called checkScore. Over here, we want to do an if statement to check if player 1 score equals to score to reach, or player 2 score equals to score to reach. Once either player reached the score required, we will simply use the load scene function to load the Game Over scene. Since the Game Over scene has been assigned to an ID of 2, we will put the value 2 over here. And we want to call the checkScore function whenever player 1 or player 2 scores a goal. Lastly, let's head up to the top and we need to add the Unity Engine.Scene Management namespace to access the Scene Manager class. Save the script and head back to Unity. Now let's head over to our Pong game scene. Select the borders object and you should see the score to reach variable. I will give it a value of 3 for testing purposes. You don't have to follow me exactly. Alright, let's enter play mode to try it out. I'm going to let player 2 reach 3 points to see if it brings us over to the Game Over scene. Perfect, now let's test the replay button. And this time round, I'm going to let player 1 score 3 points. Alright, now let's test the main menu button. Perfect, at this point, the Pong game is pretty much done. All that's left to do is to polish the game to make it better. Now we are going to add our background music. So let's head over to our main menu scene. Next, we want to create a new C# script called background music. Let's open up the script. We can go ahead and delete the start and update function as we won't be using it. And we will use the awake function instead. Firstly, we will create a private static variable of type background music called background music with a small letter B. In the awake function, we will check if background music equals to null. If it is, this will be the background music, and we do not want to destroy it. Else, if there is a background music, we will simply destroy this game object. Save the script and head back to Unity. We want to create a new game object and we will name it background music. And we want to add an audio source component. The audio source component allows us to play any audio clip we want in the scene. Next, let's attach our background music script to the background music game object. Now let's head over to our assets folder and we want to attach the music to our audio clip. Lastly, we want to check the loop option so that our music keeps repeating. Alright, let's enter play mode to try it out. Perfect, I can hear the music when I enter the game. Now let's click on the play button to see if there's music playing when we head over to another scene. Perfect, we are done with the background music. Now let's exit play mode and we want to add some sound effects to our game. Firstly, we want to create a new game object called hit sound effect. Next, we will need to add the audio source component to this game object, and we will assign the hit sound effect audio to the audio clip. Next, we want to make this hit sound effect object into a prefab. So simply select the object from the hierarchy tab, drag and drop it in the assets folder. So what is a prefab? Prefabs are a special type of component that allows fully configured game objects to be saved in a project for reuse. So if we select the prefab we just created, you can see that it saves all the components we have added for the object. And if we were to drag it back into the game, you can see that it is the same and we do not have to reconfigure it all over again. Alright, let's delete the hit sound effect prefab in our game for now. Now we want to head back to our ball bound script. Firstly, we want to create a new public game object called hit_sfx. Now let's head down to the onCollisionEnterToDe function and we want to instantiate the hit_sfx game object whenever there is a collision. Instantiate basically means that we are creating this object in-game. So we will instantiate the hit_sfx object at the ball current position and rotation. Save the script and head back to Unity. Let's head over to our Pong game scene. Let's select our ball object and we want to assign the hit sound effect prefab to the hit_sfx variable. Let's enter play mode to try it out. Alright, we are now able to hear the sound effect because whenever the ball collides with an object, it will instantiate the hit sound effect prefab, which you can see in the hierarchy. However, you will notice that the prefab instantiated isn't being destroyed after it has fulfilled its purpose. And over time, if we were to keep playing the game, the number of prefabs will just keep increasing. And eventually, it will cause the game to lag. So right now, we need a way to destroy the prefab once it has fulfilled its purpose. So let's exit play mode and we want to head over to our scripts folder and create a new C# script called destroy sound effect. Let's open up the script. We do not need the update function, so let's go ahead and delete it. Now in the start function, we will just simply destroy the game object, and we need to let it know how many seconds till it get destroyed, which we will give a value of 1, which means this game object will be destroyed after 1 second. Save the script and head back to Unity. Now let's select our hit sound effect prefab and let's head over to our scripts folder. And we want to attach the destroy sound effect script to our prefab. Alright, let's enter play mode to see if our prefab gets destroyed. Perfect, you can see that our hit sound effect gets destroyed after 1 second. Alright, all that's left to do is to add the glowing effect. The first thing we need to do is to import the post-processing package. Click on the window tab at the top of Unity and open up Package Manager. Now over here, we want to change it to Unity Registry and search for post-processing. Once it shows up, we want to install the post-processing package. It's going to take like a minute to install. And once you are done, hit back to the scene window. Now let's head over to our assets folder and we want to create a post-processing profile. Let's just name it post-processing profile. Next, let's select our main camera object and we want to add the post-process layer component. Now let's head up to the top of the inspector tab and you can see a layer option. Click on it and we want to add a new layer. We will name our new layer post-processing. Let's select our main camera object again and under the post-process layer component, we want to change the layer field to post-processing. Now we need to create a new game object which we will name it post-processing volume. Let's select the object, change the layer to post-processing, and we want to add a new component called post-process volume. Next, we want to enable the isGlobal option and assign the post-processing profile we created earlier to the profile field. Now let's click on the Add Effect button, and we want to add the bloom effect. Expand it up, and you will notice that all the options are currently disabled. We just need to enable the intensity option. Now if we were to increase the intensity, you will notice your game object in the game starts to glow. And I'm going to give it a value of 10. You don't have to follow me exactly, but make sure you don't make the intensity too high, else your game will be too glaring. Alright, we are done with our Pong game scene. Now let's head over to our main menu scene. Select the main camera object and we want to add the post-process layer component. Now change the layer field to post-processing. Next, let's create a new game object and we will name it post-process volume. Change the layer to post-processing and add the post-process volume component. Next, enable the isGlobal option and assign the post-processing profile to the profile field. Perfect, we are done with the main menu scene. Now all that's left to do is the game over scene, so let's head over there. Select the main camera object and we want to add the post-process layer component. Change the layer field to post-processing. Next, let's create a new game object and name it post-process volume. Change the layer to post-processing and add the post-process volume component. Next, enable the isGlobal option and assign the post-processing profile to the profile field. Congratulations, you have completed the Glowing Pong tutorial. Now all that's left to do is to build the game and play it with your family and friends. To build the game is pretty simple. Head over to the File tab at the top of Unity and click on Build Settings. Next, click on the Build button and we want to create a new folder called Glowing Pong, and we will simply build the game in this folder. I hope you have learned something from this tutorial. Don't forget to click on the like and subscribe button if you enjoyed this video, and feel free to check out my other Unity tutorials as well. I will see you guys in the next video. Peace.